crazies. I'm sorry that I've been forgetting this for several class periods now, but Mike has been dying to tell you all that he loves you and that he misses you, doesn't know how life's going to continue without you for some time. So there you go, Mike. You're welcome. We miss you too, Mike, and I miss all of you guys. I hope you miss our time together as well. I'm sure, as Andelin likes to put it, well, I missed you guys. I didn't miss math class, though. That's probably true. I do. I miss hanging out with you guys. You're a lot of fun, and you know, maybe we'll get to again at some point sooner than later, hopefully. We're going to be dividing radical expressions today. Now, yesterday we multiplied radical expressions, and today we're going to be doing something new in dividing them. And kind of like before, we've already divided radicals, but not radical expressions, like where you have binomials, like we did with multiplication. So that's what we're going to be doing today. I think you'll find it fun, maybe a little bit. If you look at the board, you'll see we only have 3 problems to do. I know my green's getting faint, but I just changed black markers, and it's a strong black marker. It's bright, isn't it? It's the way we like it. So, we're going to be dividing radical expressions, and I'm going to give you guys a couple of helpful rules. Okay? A couple of helpful rules. Now, before, whenever we were trying to simplify something that had a radical in the denominator, we still can't have radicals in the denominator for our simplified answer. You okay with that? I hope so, because that's the way it is. You still can't have a radical in your denominator for your answer. But the way we would get rid of that before is we would just multiply, like if we had the square root of 3, we could just multiply, or even a number in front, it'd be the same thing. But if it were one term, we just multiply by the square root of 3, and square root of 3 times square root of 3 would be square root of 9, and that would turn into a number like 3. And then we'd be done with it. But look, when you have binomials, or 2 numbers, because they're separated by an addition or a subtraction sign, you can't do that, and here's why. If you were to, sorry, my allergies getting pretty bad, horn honking or something, huh? But if I were to multiply both expressions, which I would have to do if I'm doing the 1 on the denominator, by square root of 3, yeah, that would get rid of my square root on that one, but then I would have for this one 5 square root 3. You see why if you multiply by the square root of 3, this one gets that treatment too, and you're going to be left with 5 square root of 3 on the left, even though you have a plus 3 that's simplified from square root of 9 on the bottom right. So you can't just do that, and here's the other thing. You can't multiply this by itself, 5 plus the square root of 3, because then that's a perfect square, and that means you're going to get a middle term, which is the combination of these multiplied by each other times 2, if you recall what the perfect square rule is. And so that's not going to work either to get rid of it. So here's the trick, guys. Whenever you're dividing radical expressions and you have a binomial in your denominator, you have to multiply by the conjugate. And you remember what the conjugate is? It's the same thing as a binomial expression as this. So 5 square root 3, but the sign in the middle is different. That's a conjugate. So 5 minus square root 3 times what your denominator currently is, 5 plus the square root of 3. Okay, and whatever you do to the bottom, guess what? You have to do to the top. And so on top you're going to have 5 minus square root 3 as well, and both the numerators and the denominators are going to be multiplied by each other. Okay, now here's where it gets fun. Stay with me, okay? What we have to do, guys, just like in multiplication, now we are multiplying to solve this division problem. We have to FOIL those times each other. So let's just go ahead and let's start from the top, all right? It's what we have to do. What is 4 times the first expression in that second binomial? What's 4 times 5? That's easy. That's a whole number 20 here. Let me change markers. It's getting pretty faint, isn't it? I think that one's about shot. So I'm going to toss this to the side, and I am carrying all my fresh markers in here for whenever these that are about done go out. Like I told you, I changed my black, now I'm changing my red. We're in good shape. So let's do this again. 4 times 5 is 20. Ah, that's a lot stronger, isn't it? 20, okay? And then 4 times negative square root of 3 is going to be plus the 4. Or I'm sorry. No. Making an early mistake, aren't I? Hey, we're doing something. We're okay with that. Let's put these in front. Remember, understood between that negative sign and the square root symbol is a 1. Okay? That helps us. Helps me anyway. So, okay, 4 times negative 1 is negative 4. And then you have square root of 3. You see, that's all multiplied, those two terms together, to form 1. Negative 4 square root 3. Okay, now let's do the second part of the binomial, the first one, which is square root of 3 times 5. That's going to be plus a 5 number on the outside times the square root of 3. And then we have one more for the numerator. The square root of 3 times the negative square root of 3 is going to be negative, then square root 9. Okay, negative. Then square root 9. Well, what's the square root of 9? Well, that's 3. So let's just go ahead and simplify that. 2 of 3. So we good with that so far? 20 minus 4 square root 3 plus 5 square root 3 minus 3. Now we're going to put all of that over the bottom, the denominator. Now, with this one, however, could we FOIL it all out? Yes, absolutely. But the denominators are going to be a lot easier than most of the numerators, and here's why. They are conjugates. So let's not FOIL it all out. This is like the 4th lesson we've had on difference of squares and perfect squares, and so far, by this point, even though I will continue to tell you, if you need to, FOIL it all out so you make sure you get the right answer as long as there are no mathematical errors. That's true, but by this point, guys, we ought to be able to do the shortcuts. The rule for a conjugate is, as a result, the difference of a square, which means this. I can just take the first term and square it. And the first term is 5. What's 5 times 5? 5 times itself is 25. Okay, 25. And what is the second term? I take the second term and square it. And either way, because they're the same, it doesn't matter. I'm going to take the second term and square it. What's the square root of 3 squared? Or in other words, the square root of 3 times the square root of 3 is the square root of 9. And what is the square root of 9? The square root of 9 is 3. And so my two numbers are 25 and 3. And my whole purpose of doing it was to get rid of the radicals. And so I've done that, and I've been successful in the endeavor. Now, the difference of squares, remember, you have the first number squared, 5, which is 25. You have the second number squared, and when it's the square root of 3, you just drop the square root symbol, which is 3. And it's the difference, though. When you have conjugates, it's the difference of squares, meaning the sign in the middle is minus. I'm not done, though, am I? Because I can combine like terms here, here, and here. So let's do that right now. And I'm going to write those down over here. I'll let it stand for a while since I've run out of space. And then I'll erase whenever we get to number 3. Okay, so let me switch sides here. For our numerator, number 1, that's a like term with the last one because they're both just whole numbers. It's as simple as what's 20 minus 3. 20 minus 3 is 17. Okay, and look at these two. Base of square root, the base is square root of 3, the base is the square root of 3. So I can keep the base of the square root of 3 and just do the signs of the numbers in front of those terms that have the same base. They're like terms. So what's negative 4 plus 5, or again, I prefer it this way, 5 minus 4. It's a lot easier to see in my opinion. What's 5 minus 4? That's a positive 1. So look, I would write plus 1 square root 3. Only we understand that that 1 is implied and does not need to be written. And so actually, all I would write in simplifying, negative 4 square root 3 plus 5 square root 3, all I would do is just write plus a single 1 square root of 3, and that single 1 is understood, so I don't write it. So does that make sense how I got to the numerator? 20 minus 3, they're like terms, is 17, and because these are have the same base of square root of 3, they're like terms, and all I do is combine the numerals in front of them. And 5 minus 4, or negative 4 plus 5, either way is the same, is 1 square root 3, and that's a positive 1, but because it's understood to be a 1 in front of the square root, I don't write it. So my numerator is 17 plus square root of 3 over, let's simplify our denominator, two like terms. What's 25 minus 3? You got it, 22. And so my answer is, for number 1, 17 is 17 plus the square root of 3 over 22. Okay, I'm going to leave that there just for a couple of minutes, and I'm sure you already have it down if you're taking notes. And you guys are all good note takers, by the way. I appreciate that, but I'll leave it up just in case you need to, and we'll erase when we get to 3. So let's do number 2 now. We have in one binomial parentheses the square root of m minus the square root of n. That's hard to enunciate properly and not sound confusing. Close parentheses divided by, open parentheses, square root of m plus the square root of n. Okay, so first thing I'm going to do, guys, that doesn't help a lot, does it, written that way? First thing I'm going to do is line them up properly. I think that helps a whole bunch. And so let's put on top square root of m, I should say, minus the square root of n. Okay, let's go ahead and keep those in parentheses. I might as well, because we're going to be multiplying things by them anyway. Over, divided by, square root of m plus the square root of n. Okay, guys, do you recall, look at my denominator. My denominator is square root of m plus the square root of n. How do I get rid of, what's the only way as a rule, and without going through and explaining it all again, what's the only way as a rule I can get rid of my radical denominator? It can only be by multiplying the entire thing by the conjugate, which is, kicking toys around the room, kids' toys, frying pan, that one is, yellow baby frying pan. Okay, the conjugate of square root of m plus the square root of n, it's the same thing, square root m and square root n. The only difference is the sign in the middle. It's going to be a negative instead of a positive. And so whatever I do to the bottom, I have to do to the top, and that's a negative. So square root of m minus the square root of n. Whatever I multiplied by on the bottom, I have to multiply with the same thing on the top. Now, I will tell you this, on the top, look, that's a perfect square. And so we could take the shortcut to the perfect square. I'll be honest with you and say I think it would be a little bit confusing for us to do that at this time. So I won't do it, but only for that reason. I would much prefer to do that because, man, is it easier, a lot faster. Instead, we're going to go ahead and FOIL this one out on the top. Now, we're not going to go into on the bottom because it's just the same rule after the same rule after the same rule conjugates, so that's easy to duplicate that a million times. I don't want to get confused, though, with the top one. So what we're going to do for the top, we're going to FOIL it out. What's the square root of m times the square root of m? That would be the square root of m squared, which can just be simplified. The square root of m squared, the square root and the squared take care of each other, and it just leaves one of those. What would that be? An m. But does it make sense? M, the square root of m times the square root of m is the square root of m squared. The square and the square root cancel each other out. They're inverses, and just leaves you with a single m. So let's go ahead and simplify that off the bat. For the second one, the square root of m times the negative square root of n is going to be minus, and that's understood a 1 in front, right? For right now, before our simplification, I'm going to go ahead and write that. I think it makes it easier. Minus 1 square root of m times n, because they're both under square roots, and we're just going to put them under a big happy square root family, okay? Now we have negative n, and that's understood, a 1 between there. We can go ahead and write that if we want. Negative 1 square root of n times the square root of m is going to be another negative 1 square root. They're both under it, so let's just put them into the same happy family. Let's make them reconcile their differences and no longer be divorced as a square root family. So minus 1 square root mn again, and then the last one, the square root of n, negative square root of n I should say, times the negative square root of n. What's that going to be? Negative times a negative is going to make it a positive. Negative 1 times negative 1 is going to be a positive 1. Okay? We understand that, so I'm not going to write that in. I'm just doing it here because we're going to have to combine these two, and I think it helps to have it written that way. But what is the square root of n times the square root of n? Those two negatives will make a positive, plus the square root of n squared. Square root of n times the square root of n is the square root of n squared. Just like m, those processes, the square and the square root, cancel each other out. So let's just rewrite it simply as n. Alright, now that's our top. Okay? And that's all going to be over what as our denominator? And how about I put a little squiggly line between these to know that this is a separate reducing line, okay? Look at my denominator, which is right here. It's hard, isn't it, when you get all stacked on top of each other and especially close together. These are conjugates, guys. So what that means is that it's a difference of square. All I have to do is take the first term, which is m, and square root of m and square it. The square root of m times the square root of m is the square root of m squared, just like we did right up here. And that's going to be simplified as m, because the square root of a squared anything, they knock each other out and you're just left with the term itself, which is m. You take the second term and you square it. What is the square root of n? Hard to say all these. What's the square root of n times the square root of n? That's the square root of n squared. The square root and the square knock each other out and you're just left with the term itself, n. Conjugates, guys, results in a difference of square, meaning it's a minus sign between. Now all we need to do is combine some like terms. Okay, on top we have, let's do our little squiggly line saying this separates everything. On top we have m, and look, we have the same base with square root of mn, square root of mn, and so we're going to keep square root mn, but what I can do is just combine through addition or subtraction, in this case subtraction. I can just combine the coefficients or the numbers in front of that square root term together. What's negative 1 minus 1? Negative 1 minus 1 is negative 2. So I have m minus 2 times the square root of mn, keep your base, plus n over m minus n. That's it. That's simplified. I know it kind of looks like, well, can I knock that out? And can I kind of knock that out? Kind of, not really. And here's why. Remember, it's different when you're dealing with binomials and trinomials and being added and subtracted. You got to be careful about trying to knock things out too much and too quickly when you're not mathematically allowed to do so. So that's the simplified answer for number 2. M minus 2 times the square root of mn plus n over m minus n. Not exactly easy, but it is something that's doable. Now obviously by this point I'm going to erase our number 1 answer over here on 3 to give us plenty of space to work this one. Okay, 3 square root of 2 plus 4 over 2 square root of 3 plus 5. So where do I begin on this one, guys? What do you think? Now recall, the way I get rid of a radical, and the only way I can do it in expressions, meaning I'm dealing with binomials, the only way I can possibly do that is multiply that denominator by its conjugate, which are the same terms, just with a different sign in the middle. And so what I'm going to do is go ahead and set up my multiplication, my division line. I think I'll go ahead and slap some parentheses around these binomials, and I will make them as well around my new ones. I'm just going to rewrite what this is, my denominator, the terms themselves, with the only difference being instead of a positive sign, it has to be the conjugate or the opposite. It's going to be a minus sign. And whatever I do to the bottom, I have to do to the top. So I'm going to multiply 2 square root 3 minus 5 on top, just exactly like I'm doing on the bottom. Remember, the top one's going to take a little bit more time because I have to FOIL the bottom one because it's a conjugate. It's going to be a shortcut. The difference is squared. So let's take our time and make sure we do the top one correctly. This is a little more challenging. We have numbers, kind of like we did over here. We have numbers, but a number greater than 1 in front of that square root symbol. So let's multiply FOILing this first term in the top binomial times the first term in the second binomial on top. Okay, 3 square root of 2 times 2 square root of 3. Look, I multiplied the numbers outside the square root symbol first. What's 3 times 2? That's 6. Then I multiply the numbers inside the square root, all for the same term. What's 2 times 3 inside the square root symbol is 6, and I leave those two that were originally inside the square root symbol still under it. So 6 square root of 6 for my first term. My second term, 3 square root of 2 times the second term, negative 5. That's a whole number. All I do is multiply this whole number times that whole number. 3 times negative 5 is negative 15. And leave the only thing in those two terms that we're now combining through multiplication that was under the square root symbol, which is 2. Alright, for now my second term in the first binomial on top. 4 times 2 square root of 3. Just multiply the two whole numbers by each other, keep your sign, plus 8. I have no other square root by which to multiply, so I just keep my square root of 3. And now I multiply just two whole numbers, no square root at all in this one. Positive 4 times negative 5 is negative 20. So that's my whole expression added and subtracted on top. Okay, and now for this one, it's pretty easy. It's conjugates. So I take the first term and I square it. What is 2 square root of 3 squared? Well, here's what I'm going to have. 2 squared. What's square root of 3 times the square root of 3? Square root of 9. Okay. And then for my second term, remember, conjugates make a difference in squares. So this time instead of weighting, I'm going to go ahead and put my minus sign. But I'm going to look at that second number, term, which in this case is just a number, 5, on the bottom. And I'm going to square 5. 5 times 5 is 25. Very good. So, here's what I have, guys. On top, I have 6 square root of 6 minus 15 square root 2 plus 8. Let's do like we did before. Let's put us some squiggly lines between so it helps to kind of eyeball where we are. Okay, plus 8 square root 3 minus 20 all over. Okay, what is 2 squared? 2 squared, or 2 times 2 is 4. Okay, what's the square root of 9? That's 3. And look, these two are multiplied by each other, so 4 times 3, which is the square root of 9, minus 25. And to save space and not rewrite all that numerator again, let's just combine these right here. What is 4 times 3? That's 12. So let's just rewrite it as that. Okay. So we have 12 minus 25. What's 12 minus 25? That's a positive number, that's a negative, so let's just subtract them. And let's say we have 25 minus 12. Whew, that hurts on a hardwood floor. Wish you could see my smashed kneecap right now for that long. So, and I'm getting to be an old man too. So, all right, so 12 minus 25, opposite sign, so we're going to subtract the smaller from the larger. 25 minus 12 is 13, and the larger of those two is a negative, so it's going to be what kind of a 13? A negative 13. And look, I'm just going to cross all that out and write negative 13. Are you okay with that? Again, I'm just saving having to rewrite, and just simplifying what that denominator is. So our denominator is only all that over negative 13. Here's something we have not experienced yet up to this point, guys. When you have a single term on the bottom as your denominator, which is a beautiful thing, when you have that and you're dividing radical expressions, and of course if you have a denominator, you're dividing because that's what a denominator does. It divides a numerator, a whole. If you have a negative, it's kind of like having a radical. You can't do that in simplified form. And so what you need is a positive number on bottom. And you might say, what? I quit. This isn't fair. Well, stay with me because it's really not that hard to change that. All you do is change the sign of everything on top, and then you can also change the sign on bottom. You hear that? To change the sign on bottom from a negative 13 to a positive 13, all you have to do is change every sign of the whole number, not underneath the square root, because that'd be untrue then. But every number, change the sign in front of the number itself, and then you're golden. So watch. Let's do a little squiggly line right here to celebrate. It's getting late, Mike. What am I trying to say? To separate. There we go. Good stuff right there. This is my third math class, by the way, of the night, so that is worth anything. Okay, so negative 13 is going to become a positive 13, but to do that, I have to change the sign in front of every term on top. Now look, I had a positive 6 up here, so now guess what kind of 6 I'm going to have? That's right, it's going to be a negative 6, but I keep the base, square root of 6, exactly the way it is. Now, the whole number, 15, used to be a negative. Guess what it's going to be now? That's right, a positive. Plus 15, but the base of a positive square root of 2 stays exactly the same. Okay, I had a plus 8. Guess what I have now in terms of an 8? You guessed it, minus 8, but my base, square root of 3, does not become a negative underneath that square root sign because then that would be a false statement. Remember, you can't have a negative number underneath a square root, even though you can have a negative number or a negative sign on the outside of it. And then lastly, I had a negative 20, so guess what kind of 20 I have now? Bingo. It's now a positive 20. You see, all I do is change all the signs in the numerator in front of numbers themselves if I want to change the sign of the denominator. And don't forget that, guys, just like you can't have a radical as a simplified answer in the denominator, so also you cannot have a single negative number or term, maybe a better way of stating it, in the denominator. Now if you look over here, if I have 2 terms, I can have one of those being negative because there's no way to make them both positive if one's a negative and one's a positive. You just can't do that. And so that's okay if you have 2 terms, but whenever you have just a single term, it has to be positive. All right, guys, that is it for your Wednesday. We have one more day of math left.